Hello, good afternoon, everyone. Good afternoon, everyone, and welcome to today's class. So, we are going to look at few examples, or rather, few questions, past questions on GCE exams, physics exams. Okay, so if you're preparing for this year, November, December GCE exam, or next year, 2025 GCE exam. So, this past questions is very, very important for you to go through it while you prepare for your forthcoming exams. Okay, all right, I want you to stick to the end of this class so you can have a wide knowledge on some questions and how you can approach them. Thank you for stopping by. All right. All right, so let's look at this example. How long will it take to heat 3 kilograms of water from 28 degrees Celsius to 88 degrees Celsius in an electric kettle taking 6 amperes from a 220-volt supply? And we're given the specific heat capacity of water to be 4,180 joules per kilograms per Kelvin. Now, this topic, this question is under a topic called specific heat capacity. Okay? Now, if you ask what is specific heat capacity, specific heat capacity is the quantity of heat required to raise the temperature of a unit mass of a substance by 1 Kelvin. Okay? Now, let me explain further. The quantity of heat applied to a particular body is proportional to the mass of the body and the temperature difference, right? Now, if we remove these proportionalities and introduce a constant, so we have H is equals to mc theta. Now, this H is the quantity of heat. In some textbook, we can see what? Q is still the same thing as quantity of heat, which is measured in joules. M is what? Mass, which is measured in kilogram. Theta is temperature, measured in Kelvin. And C is the specific heat capacity, which is the constant. Okay? Now, in this question, we're actually using what we call an electrical method. The quantity of heat here is electrical heat. Okay? The quantity of heat here is electrical heat. Now, we are not using H to solve. Electrical heat, electrical energy, electrical work done is the same and is equals to IVT or I square RT or V square over RT. Okay, now you're going to look at the one that will best suit what we have. We equate it with this MC theta. Okay, because we're using the electrical method, we're no longer using this quantity of heat H. We are using the electrical method. And the quantity of heat in the electrical method is electrical heat, electrical work done, electrical energy. They are equal to these three formulas. Now, depending on the parameters given to you, that will best suit what you have, you know the particular one that will fit into what you have, then you solve your problem. Are we clear? All right. Now, how long in physics means what? Time. But how far in physics means what? Distance. So we are actually looking for what? For the time. So let's proceed. All right. How long, that is T, is what you are looking for. Taking to heat 3 kilograms of water, this is our mass. So our mass is 3 kg, and the temperature ranges from, the first temperature is 28 degrees Celsius, that is my theta 1, to be 28 degrees Celsius to 88 degrees Celsius. That is my theta 2. Okay? All right. And a current of what? That is I, current of 6 amperes, and the PD, potential difference, of 220 volts, right? And we're giving specific heat capacity of water, that is C, W, to be 4180 joules per kilograms per Kelvin. Now, these are the parameters given. So you are going to use what we have to find our problem. So the formula we are going to use for the quantity of heat, H, is replaced with IVT, because we have current, potential difference, and what? Time. Then it is equal to what? MC theta. The theta equal to now be what? Theta 2 minus theta 1. Because we have two different temperatures, we are going to subtract from them, from each other, to get a temperature rise. For the situation whereby we have just a temperature rise, what we are going to do is just to multiply by a temperature rise. Is that okay? All right. So let's go. My current is given as 6 multiplied by potential difference is 220 multiplied by what? T, because I'm looking for T. Now, what is my mass? My mass is 3 multiplied by my specific capacity of water is 4180 brackets. What's my theta 2? 88 minus my theta 1 is what? 28, right? So I'm going to use our calculator to multiply and see how we get our time. With the help of calculator, we'll say 6 times 220 is going to give me 1320T is equals to, right? Let's multiply this. 980 0, okay, times the difference between this and this, that is 88 minus 28. It's going to give me 60. So I multiply by what? 60, right? So let me break it down by saying 1320T is equals to 12,540 multiplied by 60. And my answer becomes 75200, right? Then I divide both sides by 1320. 1320, okay? Then if this cancels this, I'm going to have what? T, okay? Then I'll divide 752,400 divided by 1320. So my answer becomes 570 what? Seconds. Is that clear? All right. Peace, Osakwe. Thank you so much for staying to this class. Okay, Chukwu, thank you so much. I really appreciate. All right, let me do a recap. Let me explain it again. The question says, how long will it take to heat 3 kilograms of water from 28 degrees Celsius to 88 degrees Celsius in an electric kettle taking 6 amperes from a 220 volt supply? Given that the specific heat capacity of water is 4,180 joules per kilograms per Kelvin. Now, how do we do that? In physics, when you hear how long means time, and when you hear how far means distance, okay? Now, I have the mass. The mass is given as 3 kilograms. The initial temperature is 28 degrees Celsius, while the final temperature is 88 degrees Celsius, okay? Then the current is given as 6 amperes, potential difference is 220 volts, right? And we are giving the specific capacity of water to be 4,180 joules per kilograms per Kelvin, right? Okay, so using our formula, IVT is equals what? MC bracket theta 2 minus what? Theta 1, right? We substitute into what we have. We have our current as 6, potential difference as 220, and my time is what I'm looking for, okay? Then it's equals to my mass as 3, my C as 4,180, then in bracket, my theta 2 is 88 minus what? 28. Right. By the time you subtract, you're going to get what? 60 what? Degrees. Now you multiply out to get 7,752,400, right? Then we divide by the coefficient of t, which is 1,320, and our answer landed to be what? 570 seconds. Is that clear? Right. All right, so let's look at this second example. A 420 watts, that is power, electric heater is used to heat water of mass 50 kilograms from 25 degrees Celsius to its boiling point. Boiling point. Full stop. How long in hours does the electric heater work? Let me go again. A 420 watts electric heater is used to heat water of mass 50 kilograms from 25 degrees Celsius to its boiling point. How long in hours? That is, they're looking for time, but it's going to be in hours. Does the electric heater works? Now, it's similar to what we used before, right? This electric heater, what here we're going to use PT is equals to MC theta, right? But there is something we must take into consideration. Let us set our parameters. My power is equals to 420 watts. Then I have my mass to be 50 kilogram. Okay. Then my initial temperature is 25 degrees Celsius. Once you hear boiling point, the boiling point of water is 100 degrees Celsius. Temperature goes from 25 degrees Celsius to 100 degrees Celsius. That becomes my theta 2. So theta 2 is 100 degrees Celsius. Okay? Then how long is time? Well, the time must be in what? In hours. So for the time to be in hours, we must first get the time in seconds, right? Okay, to convert it. All right. Then the specific heat capacity of water is 4.2 times 10 raised power what? 3 joules per kilograms per what? Kelvin. Now let's use our formula to solve. My P is power. I will say PT is equal to what? MC theta, right? My power is 420 T, right? Is equal to my mass is what? 50. Okay. Then my specific capacity is giving us 4.2 for 3, which is the same thing as 4200. Okay. This is a standard form of that. Then multiply by my theta 2 is 100 minus what? My theta 1 is 25. Okay. So let's work it out. I have 420 T is equals to, right? Let's work it out. This is 50 times 4,200 multiplied by, okay, I'm going to have 75, right? Okay, let me multiply to see what I have. I bring down 420 T. Then I go 50 multiplied by 4,200. Then multiply by 75. I'm going to have 15750,000. Okay. Then the next thing I'm going to do is to divide both sides by the coefficient of T, which is 420. All right. If I divide by 420, I'm going to have 37500 seconds. All right. But they say they want it to be in what? In hours. They want it to be in hours. So how do we get it in hours? How do we get it in hours? You're going to divide by what? You're going to divide by what? You're going to divide by what? All right. If you remember that, let me do a short review here. Remember that 60 seconds give me what? 1 minute, right? Okay. Then we still remember that 60 minutes give me what? 1 hour. Now, if you decide to convert it, you're going to convert it to minutes and also do what? Convert it to what? To hour. So you're going to divide by 3,600. Okay? Because 1 hour is equal to 3,600 seconds. Exactly. So if I divide by that, I divide by 3,600, I will say divided by 3,600. So my answer is going to be 10.42 approximately what? Hours. Do you get it now? What I just did? Let me go again. After setting our parameters, a 420 watt electric heater is used to heat water of mass 50 kilograms from 25 degrees Celsius to its boiling point. Boiling point means the boiling point of water, which is 100 degrees Celsius. Okay, and that becomes the final velocity, right? How long in hours does the electric heater work? And we are giving the specific capacity of water to be 4.2 times 10 raised to the power 3 joules per kilograms per Kelvin, and we have our options. All right, setting our formula because we're using the electrical method, right? So we have power is equals to this. We have mass, initial temperature, final temperature. We're looking for time, and this is what we have as what? The C of water, that is specific capacity of water. All right, so setting our formula, we have PT is equals to MC star. What's my P? My P is 420 multiplied by T. Then this is equals to what? My N is 50. My C is 4,200. Then my difference in temperature means the same thing as saying what? MC bracket theta 2 minus theta 1, right? It's still the same thing as change in what? Temperature. So when I got to that point, my theta 2 is 100 and my theta 1 is what? 25. Then I subtracted to get 75 and I multiplied to get 1,575,000, 750,000, right? Then is equals to 420T. Because I'm looking for the time, then I divide by the coefficient of T, which is 420. When I divide, I now got what? 37,500 seconds. But they want our answer to be in what? In hours, not in seconds or in minutes. We now remember that 60 seconds is equals to what? 1 minute. And 60 minutes equals to 1 hour. Okay? So it means that in 1 hour we have what? 60 times 60 seconds. That is, in 1 hour we have 3,600 seconds. Now, since we want to convert it to hours, we're going to divide this value by 3,600 seconds, right? And our answer is what? 10.42 approximately hours. All right? So it means that the correct option here is what? Option A. Do you understand? Right. All right. So let's look at this question on the board. Mass. Number 3, ice of mass 10 kilogram at minus 5 degrees Celsius was completely converted to water at 0 degrees Celsius. Calculate the quantity of heat used. Now, if you're looking at this question is under the latent heat of fusion. Latent heat of fusion. Okay? The situation whereby ice has melted and changed its state. What is latent heat? Latent heat is a hidden heat, which involves a change of state without a change in what? Temperature. It's just like ice. Bring out your soup. Bring out your ice block from the freezer and allow it to defroze. It will automatically change to water, even without you apply what? Heat. That process, the material or the substance has changed from solid, which is the ice block, to liquid, which is now water. But do you apply any heat? No. So it involves a change of state without a change in what? Temperature. Okay, that process is what is said to be latent what? Heat. Now, if a specific mass is used, that is 1 unit mass is used, becomes specific latent heat of fusion. All right, so let me use an illustration to explain further. All right. Now, ice in its solid state is said to be what? A solid. Now, water is what? Liquid. This should be vapor. While this is gas. Okay? Now, any ice that is here that is in its solid form is said to be what? A solid. It has mass. It has specific capacity. I have initial it has temperature difference. Okay? Now, at this point, this solid will change. At this level, this solid will change to what? To liquid. But is there any change in temperature? No. You didn't apply heat? No. So this is where we have latent heat of what? Fusion. Latent heat of fusion occur at this point. As soon as you apply heat, it will change to what? To water. Do you understand? Now, the temperature of water is the same as this until you apply what? Heat. Now, the temperature of water here is what? Is the same. Do you understand? Temperature of water is the same. From here, The temperature range, if I draw a number line to explain this is 0 degree, right? This is ice. The question ice was given as minus 5 degrees C, right? Okay. Now this is the solid state. This is the solid state of ice when the temperature is still what? Minus 5 degrees Celsius. Now it's now increased to 0 degrees Celsius. So for the ice, this is the initial temperature of ice, which is theta 1, while this is the final temperature of ice, which is what? Theta 2. Okay? Now, at this point, latent heat of fusion takes place. Because at this point, which is here, the ice is no longer solid. It is now liquid. And as it's now liquid, the temperature, it remains what? 0 degrees Celsius, which is at this point. But the state has changed from solid to liquid. But the temperature is now 0. Do you understand? All right. So we are asked to calculate the quantity of heat required to move from this ice, which is given as minus 5 degrees Celsius, to what? To water. Okay? At 0 degrees Celsius. What are we going to calculate? We're going to calculate the quantity of heat here plus the quantity of heat here. The quantity of heat here is ml what? F. Is that clear? The quantity of heat required for us to change from this ice, which was initially at minus 1 degrees Celsius, to water, because here is water at 0 degrees Celsius. But if they say to water at 10 degrees Celsius, it's no longer here, because heat has been applied to it. It will now move to this place. I don't know if you get it. So we are looking for the quantity of required to change this solid, which is ice, from here to here. This here, the ice is now liquid. It has changed to water. But the temperature is 0 because there is no change in temperature. Because you did not apply heat. Do you get it now? So I'm going to use the knowledge of what I just explained to be able to solve this problem. Right. All right, let's go. The mass given, our mass is given as 10 gram, okay? The temperature of ice, that is theta 1, is minus 5 degrees Celsius, okay? Then the final temperature of ice is always constant, which is 0 degrees Celsius, all right? And we're given the specific capacity of ice and the specific latent heat of fusion of ice. All right, so let's go. The quantity of heat, H, is equals to the quantity of heat applied to the ice plus the latent heat of fusion. Okay? Then the quantity of heat applied to the ice to melt is equals to what? MCI temperature theta 2 minus theta 1. Now, why didn't we add temperature difference here? Because in latent heat of fusion, there is no change in temperature, but there is a change of state. Okay? Now, let's go. We have the mass to be 10 gram. We have 10 multiplied by the C of ice is what? 2.1. Right? Multiplied by my theta 2 of ice is 0 minus my theta 1 is what? Minus 5. I'll put in bracket minus 5. Okay? This is equals to the mass is the same, which is 10 multiplied by the latent heat of fusion of ice is 336. Okay? So work it out. You say H is equals to, when you multiply, what do you have? I think we have 21. 2.1 times 10 times minus is what? Plus. So we now say multiply by what? 5 plus, you multiply this, we have 3360. Okay, so let's go. 21 times 5, I have 105 plus 3360. Okay, and I'll add it. So my answer becomes 3,465 joules, right? And the correct option is option what? C. Option C is what? Correct. Now let me explain myself again. They say ice of mass 10 gram at minus 5 degrees Celsius was completely converted to water at 0 degrees Celsius. Calculate the quantity of heat used. Now, for us to get the quantity of heat used, we are going to look at the specific heat capacity of ice. It's given as that. And the specific heat latent heat of fusion of ice is given as that. All right. So, if you must remember that ice in its solid state, it has mass, it has specific heat capacity, it has what? Temperature difference, okay? So, ice in its solid state has a temperature of minus 5 degrees Celsius. Now, by the time it will melt, it will now move from minus 5, which becomes the initial velocity, to now 0, which is now final velocity. Is that okay? All right. Then when it comes to 0, at that same point, it has changed to liquid, no longer in solid form. At that point, we say the latent heat of fusion of ice has taken place. Is that okay? All right. So we're asked to calculate the quantity of heat. And that heat, you're looking for the quantity of heat here. And the quantity of heat required to convert that ice to what? To liquid at a constant temperature. Okay? So we substitute it to what we have. The mass is given as 10. The C of ice is given as 2.1. The initial temperature of, the final temperature of ice rather, is 0 because it's constant. Okay? Minus, the initial temperature of ice is minus 5. Alright? Then plus this is 10 multiplied by this, right? Now bring it down, this multiply, got 21 multiplied by minus times minus is plus. Bring out what? 5 plus 10 multiplied by 336 is going to give us 3,360. Okay? So by the time you multiply 21 by 5, I got 105. Now add it to 3360 and my answer becomes 3,465 joules. Is that clear? So this is how to solve on this type of question. Right. All right, let's go to the next question. let's look at this example. A machine of velocity ratio 6 is used to lift a load of 120 Newton. If the efficiency of the machine is 80%, calculate the magnitude of the effort applied. Let me go again. A machine of velocity ratio 6 is used to lift a load of 1,200 newtons. If the efficiency of the machine is 80%, calculate the magnitude of the effort applied. Now, one thing that will come to your mind is this, that the efficiency of a machine is equal to mechanical advantage over velocity ratio, then multiply by 100%, because the efficiency is expressed as a percentage. Okay? Now, if you're asked what is mechanical advantage, mechanical advantage is load over effort, as the ratio of the load to the effort, and velocity ratio is the distance moved by effort. The ratio of the distance is moved by effort to the distance moved by what? Load in the same time interval. All right, in this question, you're given a velocity ratio of 6, and you're given a load of 1,200 newtons with efficiency of 80%. They asked to calculate the effort. Now, we cannot solve for the effort without solving for the mechanical advantage first. We are going to solve for the mechanical advantage. Then when we are done solving that, we are now going to substitute it in here to solve for our what? Effort. Is that clear? All right. So let's solve. All right. So my efficiency is given as what? 80%. Velocity ratio is given as 6. Okay. Then the load is given as 1,200 Newton. Then we are looking for the what? Effort. But do we even have mechanical advantage? No. We don't have mechanical advantage. So let's substitute into the formula and solve what we have. Okay? So look at the efficiency. We say 80 over 1. Why did I not put over 100? Because the formula already have multiplied by 100. If not, I would have said 80 over 100. All right, so it's equals to MA, which is the mechanical advantage, divided by velocity ratio is given as 6. All right, multiply by 100 over 1. Right? Okay, we're going to do cross multiply to get this. Right? Okay, 80 times 6 is going to give me, what do I have? Let me find out. 80 times 6. Okay, it's going to give me 480. 480, 100 times MA, I'm going to have 100 MA, right? Then because I'm looking for mechanical advantage, I divide both sides by the coefficient of what? MA, which is what? 100. This cancel. So my MA is equals to 480 over 100. This cancel this, right? So what do I have? I'll have my MA to be equal to 4.8, right? But what I'm actually looking for is the effort. I'll still remember that mechanical advantage is equal to load over what? Effort. Now, what is my mechanical advantage? I got it at 4.8. Is equal to, what's my load? My load is 1,200 divided by what? E, right? I'm going to do cross multiply. This is over 1, cross multiply. So this is 4.8E is equal to 1,200. So the next thing I'm going to do is to divide by the coefficient of E, which is what? 4.8. Okay? All right. So let's divide what we have 1200 divided by 4.8, and my answer becomes 250 watts Newton. So the answer to this question is equal to what? 250 Newton. I hope that is clear. Right. All right, are we cleared? Let's move to the next question. Let's go to the next one, which is question 5. All right, so let's look at this example. The efficiency of a machine is 80%. Calculate the work done by a person using the machine to raise a load of 300 kilograms through a height of 4 meters. And I'm giving G to be 10 meters per second square, okay? Now, this question involves efficiency and work done. Okay, apart from the efficiency of a machine being equal to mechanical advantage divided by velocity ratio, we can still say that the efficiency of a machine is equal to work output over work input. Okay, all right. So we can say that the efficiency is equal to work output over work input. Then multiply by 100%. Okay. Now the question is, what is work output? What is work input? For example, we are using wheelbarrow to carry load. Okay, we are using wheelbarrow to carry load. The work output is the load that wheelbarrow is carrying, the mass of the weight that the wheelbarrow is carrying. But the work input is the energy you put on the wheelbarrow to carry the load. I don't know if you understand the two concepts. The work output is the load that the wheelbarrow is carrying. That the load is the force that the wheelbarrow overcame. Okay, but the work input is the energy, that is the force applied to a machine. That is the energy you're using to carry that machine, which is the wheelbarrow. That is the work input. Okay, so what you're looking for is the work done by a person using this machine to raise a load of that. Okay, so you're looking for work put into the machine to carry that load. So let's set our parameters. Our efficiency is 80%. Okay, then we're looking. That is what you are looking for. We have the mass, and the mass is 300 kilograms. Then we have the height. The height is the distance moved by the load, which is 4 meters, and G is giving us 10 meters per second squared. Is that okay? All right. So looking at what we have, we get to put into our parameters. My efficiency is 80 is equal to, my work input is the same thing as saying this is load times distance moved by load divided by work input times 100 over 1, because I'm looking for work input. All right, 80 is equal to, what is load? Load is a force, right? And they gave us the mass of the load. Now for us to get the load is what? Mg. That is the mass of 300 multiplied by 10 is going to give us what? 3000 Newton. That is the load, because the load is a force, which is this force here. So we say this is 3000 multiplied by distance moved by load is 4. Okay, divided by work input multiplied by 100 over 1. Okay, so I can say cross multiply this and multiply the whole of what we have in the numerator, and this is going to give me 80 work input is equal to what? It's a 3000 times 4 times 100. Now I have 1200000. Okay, and that is, I have 1.2 million. Then I divide both sides by the coefficient of work input, which is 80. Okay, now when we do that, this will cancel. 8 is going to cancel. I have work input to be 120,000 divided by what? 80. Okay, all right. All right, sorry for that, my network. Okay, so if you divide, you say 120,000. All right, divide by 80. My answer becomes 1500 what? Joules. Okay, that's 15,000 joules. Let me do a recap by saying that They're giving the efficiency of a machine to be 80%. They have to calculate the work done by a person using this machine to raise a load of 300 kilograms through a height of 40 meters. Okay, then G is giving us 10 meters per second square. So from the formula, we get the efficiency to be 80%. We're looking for work input. Then we have the mass as 300 kilograms. Then the height is 4 meters, right? And G is 10 meters per second square. Now, since we don't have load, we're going to find the load. Load is mass times acceleration because it's a force. So that is 300 times 10 to give me 3,000 Newton. And the formula efficiency is equal to work output over work input multiplied by 100%. All right. Now, efficiency 80 is equals to, what is my work output? My work output is load multiplied by distance moved by load, then divided by work input, because I'm looking for work input, right? Okay, multiplied by 100 over 1. Then I now carry the value of my load, which I've already calculated, and it gave me 3,000 Newton. Then I substitute it into what I have, multiplied by the distance moved by the load, which is 4. Okay, then multiply by 100 over 1. If I do cross multiply, I'm saying 80 multiplied by this, I have 80 work input. Then multiply the whole of the numerator to get 1,200,000, okay, joules, right? Then I divide both sides by the coefficient of work input, which is 80, and my answer gave me what? 15,000 joules. Is that clear? And this is how you can solve problem under this type of questions or machines, right? Okay. All right, I hope we don't have a question. Let's proceed. All right, let's look at this question. Option A, 300 Newton. All right, let's solve. A block and tackle system has 6 pulleys. A force of 50 Newton applied to it lifts a load of weight W. If the efficiency of the system is 40%, calculate what? W. Are we there? Let me go again. A block and tackle system has 6 pulleys. A force of 50 Newton applied to it lifts a load of what? Of weight W. If the efficiency of the system is 40%, calculate what? W. Now, when you look at this block and tackle system, it's an example of simple machine, okay? Now, this block and tackle system of pulleys, the number of pulleys is equal to the velocity ratio. Now, since the velocity ratio given in this question is 6, since the number of pulleys given in this question is 6, that means that velocity ratio is equally what? 6. Okay? Now, for this system, velocity ratio is equal to number of pulleys. Okay? Then is equal to what? 6. A force of 50 Newton applies to lift a load. That means this is our load. Our effort is 50 Newton. And we are looking for our load, which is labeled what? W, right? If the efficiency is 40%, we should calculate what? W. The first thing that will come to our mind is for us to get our mechanical advantage, okay? Using our formula, efficiency formula, this says that what? Efficiency of a machine is equal to the mechanical advantage over multiplied by 100, okay? 100%. My efficiency is 40 over 1 is equal to MA over what? 6. Then multiply by 100 over 1. Right? By the time you multiply, you're going to get the same cross is equal to 100 MA. Okay? Then I divide both sides by what? 100. This cancel this, right? Okay, so what will be my MA? This cancel this. So my MA is equal to 2.4. Remember that MA has no XI units, okay? The mechanical advantage, MA, is equal to load over effort. But here, the load is given as W over what? Effort. Now, let's go. We say this is 2.4 is equal to W over my effort is given as 50, okay? I'll say this is over 1 cross what? Multiply my W happens to be my load is equals to 50 multiplied by 2.4. All right, let's go. 50 multiplied by 2.4. My answer to this question is equal to 120 Newton. Okay? The answer to this question is equal to All right. Into the next question, which is question 7. All right. Let's look at this example. A wheel and axle of radar, 800 millimeters and 200 millimeters respectively, is used to raise a body of weight 800 Newton by application of 250 Newton. Calculate the efficiency of the machine. Now, for us to solve this problem, we should know that for wheel and axle, we should know the velocity ratio of a wheel and axle. Okay? And the value of the velocity ratio is this, the ratio of the wheel, the radius of the wheel over radius of the axle, right? So this is the radii, which is when they are two, but when it's one, it is called radius. All right? So let's go. The first thing we're going to do is this. We say the radius of the wheel is 800 millimeter, radius of the axle is 200 millimeter, okay? Now it is used to raise a body of weight. Why this application of my effort, which is 250, okay? So my load is equal to 800 Newton and my effort is 250 Newton. We are looking for efficiency, okay? The formula for my efficiency is, I already know the formula, which is what? MA, which is mechanical advantage over what? Velocity ratio multiplied by 100%. Now we don't even have either of them. We don't have mechanical advantage. We don't have velocity separately. Then we put it here to solve our problem. Right. What's my my MA is load over what? Effort. Okay, my load is what? 800, and my effort is what? 250. So I'm going to divide to see what I have. The answer becomes 3.2, right? Okay, then my velocity ratio is equal to the radius of the wheel over radius of the axle. That is 800 divided by what? 200, right? Now we cancel. Okay, 2 into itself 1, 2 into 8 I have 4. So this becomes what? 4. Okay, now let me substitute it into what I have to solve my problem. Efficiency. Okay, what's my MA, which is velocity mechanical advantage, is 3.2 divided by velocity ratio is 4, then multiply by 100%. Okay, so let's work it out and see what I have. Now this 3.2 divided by 4, I have 0.8. So I have 0.8 multiplied by 100%. Okay, by the time you multiply, the efficiency will now be equals to what? 80%. Is that clear? Right. All right, let me do a recap. A wheel and axle of radii 800 millimeters and 200 millimeters respectively is used to raise a body of weight 800 Newton by the application of 250 Newton. To be able to solve this problem, we are going to remember to state our parameters. The radius of the wheel R is equal to what? 800 millimeters. Our radius of the axle is what? 200 millimeters. Now our load is giving us 800 Newton, while the application of this is the effort, which is what? 250 Newton. If you are starting to use this formula of efficiency, which is MA over VR times 100%, but we don't even have MA or VR, so what you are going to do is what? We work it out, then substitute into what I have. So let's go. What's my MA? My MA is what? Load over what? Effort, right? So what is the load? 800 divided by effort is what? 250. Okay? By the time you divide, I'm going to get 3.2 because it does not have any extra units. A mechanic velocity ratio, is equal to radius of the wheel or radius of the axle. So we have 800 over what? 200. By the time I divide, I'm going to get 4. So putting it into the formula, efficiency is equal to MA over VR multiplied by 100%. What's my MA? My MA is 3.2 divided by my VR is what? 4. Then I multiply by 100%. Okay, so if I divide, I'm going to get 0.8. 0.8 multiplied by 100%, and my answer becomes 80%. So the efficiency of this wheel and axle to be 80%, right? All right, so let's move to another question. All right. Now let's look at this example. This is under temperature and heat measurement, okay? The eyes and steam points of a certain thermometer are minus 20 degrees Celsius, minus 20 degree and 100 degree respectively. Let me go again. The eyes and steam points of a certain thermometer are minus 20 degree and 100 degree respectively. Calculate the Celsius temperature corresponding to 70 degree on the thermometer. Now, we have two types of scales. We have the Celsius scale, the Kelvin scale, and the Fahrenheit scale. Okay? So, in this question, we are comparing this scale of a thermometer with our Celsius scale. Let me just sketch the type of scales we have. We have this. Okay? So, we have, this is Celsius. Let me say this is degree C. This is Kelvin. This is degree what? Fahrenheit. Okay. Now the upper fixed point of this Celsius scale is what? 100 degrees Celsius. The lower fixed point is what? 0 degrees Celsius. The upper fixed point of this Kelvin is 373 Kelvin. The lower fixed point is 273 Kelvin. Okay. The upper fixed point of this is 212 degree Fahrenheit, and the lower fixed point is 32 degree Fahrenheit. Is that okay? All right, so we are asked to compare this temperature, this thermometer given to us with the what? With the Celsius temperature. We are going to compare it with this Celsius scale. But the three scales we have, they are the Celsius, Kelvin, and what? Fahrenheit. Okay, so let's see how we can use the application of this to solve our problem. I must know that any thermometer has two scales, which is what? The upper fixed point and the lower fixed point. All right, let's solve. Now, this thermometer is registered only in degree, and it has its eye degree. This is ice point, which is the lower one, minus 20 degree, okay? And the steam point at what? The steam point is 100 degree, okay? Now we are calculating it to the Celsius scale. We already know the Celsius scale, which is the degree Celsius. The upper fixed point is what? 100 degrees C, and the lower fixed point is what? And corresponding to 70 degree on this particular thermometer. When this thermometer is reading 70 degree, what will this one read? I'll call it X. Okay? Now, the formula we're going to use is, this difference is what we say to be the fundamental interval. This fundamental interval minus the lower fixed point, then divided by the upper fixed point minus the lower fixed point. Okay? Now, I have X minus 0 divided by 100 minus 0, okay, is equals to 70 minus bracket minus 20. 70 minus bracket minus 20 is equals to 100 minus bracket minus 20. Okay. Now, what do we have? So let me state it clear. I have 70 minus 20 all over 100 minus bracket minus 20. Okay. Now, x minus 0 is going to give me x over 100 minus 0 is going to give me 100 is equals to, this is 70 minus times minus is plus. All right, plus 20, right? Now, this is 100. Minus times minus is plus. I only have 20. So let me break it down. Let me add x over 100 is equals to 90 over 120. Okay? So I'll do cross multiply by saying 120x is equals to 90 times 100, okay? Because you're looking for the temperature here on this scale. So I'll have 120x is equals to 9,000, right? Then I divide both sides by the coefficient of x, which is 120. This will cancel. Now my x, I will have 9 divided by 120. So my answer is 75 degrees what? Celsius. Is that clear? Can we explain? This temperature, the eyes and the steam point on this thermometer is given as minus 20 degree and 100 degree respectively. We are comparing this scale with the Celsius scale. That's what I just did. The upper fixed point, which is the steam point, is given as 100, and the lower fixed point is given as minus 20. Okay? Now, what do we have? We stated what we have. Then the degree Celsius, we have the upper fixed point to be 100. The lower fixed point is what? 0 degrees Celsius. Now we are comparing the Celsius temperature. When this particular one is reading 70 degrees, what do we have? We're going to call it X. Use the formula. The formula is fundamental interval, which is the one in the middle, minus what? The upper fixed point minus lower fixed point. Okay? Then we have x minus 0 divided by 100 minus 0. Okay, that is what we have. Then it's equals to 70 minus minus 20. Okay, then equals to 100 minus 20. Now we brought it down. X minus 0 is x, 100 minus 0 is 100. Okay, now 70 minus times minus is plus. We have plus 20. Then divided by 100 minus times minus is plus. We have what? 20. Is that clear? So we have x minus 0 is equals to, this will give me 90, this will give me 120. Because I'm looking for the value of x, I will say cross multiply by saying x times 120 is 120x, then 90 times 100 is going to give me 9,000, right? Then because I want to get x, I will divide by the coefficient of x, which is 120. By the time I do that, I'm going to have my x, which is the temperature on the Celsius scale, as 75 degrees Celsius. Is that correct? Is that gotten right? Carlo Blessing, thank you for stopping by. I really appreciate. All right. We have 2 more questions to go. If you have questions you feel that I should explain, you can state it so that we can dive into that. All right, so let's move into another question. All right. So let's look into this equation. Number 9, the equation y equals 5 sine bracket 3x minus 40, where y is in millimeters and x is in meters, t is in seconds, representing a wave motion. Determine I, the frequency, the period, and the speed of what? Of the wave. Now we are using this progressive wave equation to find the frequency, the period, and the first thing we are going to do is to remember the equation of a progressive wave. Okay? The equation says that what? It says that y is equals to a sine bracket 2 pi ft minus 2 pi x over lambda. Okay? This is a progressive wave equation, and we are going to compare it with what we are given to find the unknown. And for us to do that, what we are going to do is to relate it with the equation given to us. Y is equals to 5 sine bracket 3x minus 40. Okay? Now, how do we solve this problem? We are doing comparison. Y is equals to y. A is equals to 5. Okay? A is amplitude, automatically is equals 5 meters. Then sine is equals sine. Now what do we do next? We are going to compare this and this. So this is 2 pi ft, and here we have 40. So we are equating this with this. Okay? We are equating this to this to get the frequency, which is what we are looking for. Then after we are going to equate this and this. Remember that this is a phase difference. It can be plus or what? Minus, right? I hope this there, what I just did is not confusing. Let's remove this. All right. Okay. So I can leave this one. All right. I'm going to equate this and this to get the value of frequency. So let's go, because I'm doing comparison. So I say the frequency I, that is 2 pi ft is equals to 40, right? Then t cancels t, and I have is equals to 4. Because I'm looking for f, I'm going to divide by the coefficient of f, which is what? 2 pi, right? Then 2 pi cancels 2 pi. F is equals to 4 over what? 2 pi. Now this is 4 divided by 2 times, what is pi? Pi is 22 over 7, or 3.142. That is 3.142, right? If I divide this one, divide this, I have what? 2. Okay? So what I'm going to do is to say 2 divided by 3.142. So my answer becomes 0.64 haze, approximately. Okay? Now let me go again. I said we are doing comparison in this question. We are comparing, this is the progressive wave equation. We are comparing with the one given to us. So after the comparison, we equate this and this, because this one has t, and this one equally has t. So let's combine them together. Other side. This is a phase angle that has a phase difference. It can be plus or minus, okay? So irrespective of its position, the sign does not change. Okay, so we compare this and this. So we have 2 pi ft is equals to 40, right? Now, what is common? T is common. You can't. We have 2 pi f is equals to 4. Because I'm looking for the frequency, I have to divide by the coefficient of f, which is 2 pi. right? So I have f is equal to 4 over 2 pi, right? Okay, so what do I have? I have 4 divided by 2 times 3.142, okay? Then I can divide this to get 1, divide this to get 2. If I say 2 divided by 3.142, my answer becomes 0.64 measured in haze. So the next thing I'm going to look, which is number 2, is what? The period. The period is inverse of frequency, which is 1 over what? F. As I've gotten this to be 0.64, I'll take the inverse to get the period. So 1 over 0.64. So let's see what I have. The answer becomes 1.56 what? Seconds, okay? The answer to this period becomes 1.56 seconds. Since I've gotten the frequency to be 0.64 Hz, I'll take the inverse to get 1.56 seconds. Is that clear? Right. All right. So let's solve the last question, which is the speed of the wave. We're going to solve for the speed of the wave. But we can't solve for the speed of the wave because we don't even have wavelength. Okay, so let's solve our wavelength. That will give us edge to solve for the speed of the wave. All right, so let's go. Let's solve. Okay, the speed of the wave, I'm going to equate this and this, okay? So I'll have, I'm trying to solve the third one. Let me guess wavelength I need to solve for the velocity, which is also the speed. So this is 2 pi x over lambda is equals to 3x, right? Then x cancels x, right? So I have 2 pi divided by lambda is equals to 3. Can I say cross multiply? 3 lambda is equals to 2 pi, right? I divide both sides by the coefficient of lambda, which is what? 3. I cancel. So what do I have? Lambda is equals to 2 pi over 3. Okay? We already know that pi is 22 over 7 or 3.142. So this is 2 times 3.142 over what? 3. Now let's work it out. 2 times 3.142 divided by 3. I have 2.095 meters. Okay? This one is just my what? It's just my wavelength. Now for me to solve for the speed, which is the speed of the wave, is equal to what? F lambda. Okay? Now we should not forget that we already gotten our frequency to be 0.64. So we say 0.64 multiplied by what? 2.095. Okay? So 0.64 multiplied by 2.095. So my answer is going to be 1.34 meters per second. Okay? So the 1.34 meters per second. Right. Is that clear? Now, let me do a recap. I was looking for my speed of the wave. And this is the formula for speed. Although I've gotten my frequency, I don't have wavelength. So what I need to do is to compare this and this to get the wavelength. That is 2 pi x over lambda is equal to 3x, right? Okay, then I cancel out. I have 2 pi over lambda is equal to 3 over 1, right? Then I say cross multiply to make it the subject. Then what do I have? I do cross multiply. What do I have? Okay, I have 3 lambda is equal to 2 pi. Then because I want to make it the subject, I divide by the I have lambda is equal to 2 pi over what? Over 3. So let's substitute because pi is 22 over 7 or 3.142. So I have 2 times 3.142 divided by what? 3. So my answer gives me 2.095 meters. Okay. All right. So I can now solve for my speed. And what is my speed? My speed is my frequency got is 0.64 multiplied by 2.095. Okay. With the help of our calculator, I got 1.34 meters per second. That becomes the speed of the wave. Is that clear? Right. All right, so let's solve the last question for today. right, let's look at this question. A ray of light incident on a plane mirror is inclined to the mirror at an angle of what, 50 degrees. What is the angle of the deviation of the ray? Now, before I go into the solving, there are some things I need to explain using a plane mirror. Now, this is a plane mirror. This is a plane mirror. This line, sorry, this is my diagram. Okay, this is a plane mirror. This is a plane mirror. Now, this line is what we call normal. This line is perpendicular to reflecting surface. This is the back of the mirror, while this is the reflecting surface, okay? We have what we call incident ray. Incident ray. Then we have reflected ray. Now, what is incident ray? Incident ray is a ray, is the direction. What is a ray? A ray is the direction at which light energy travels, okay? So if this light energy travels through this direction and is going towards the mirror, it is said to be incident to the mirror. So that's why it is called incident ray. Now, if this light energy travels this way and leaves the surface of the mirror, it's said to be what? Reflected what? Ray. Now, why is it reflected? Because this mirror is a smooth surface. Once light comes to it, it's going to do what? Reflect. And reflection is throwing off of a light. It's throwing off of light from a plain or polished surface, okay? But because this flame mirror is a polished or plain or smooth surface, so it's going to do what? Go off immediately. Now, there are some things you need to know. The angle between the normal and the incident ray is said to be what? The angle of what? Incidence. Then the angle between the normal and reflected ray is said to be what? The angle of what? Refraction. Then there's an angle between the reflecting surface and the incident ray. It is called the glancing angle. And that glancing angle is equally here. Okay? Now, if I extend this incident ray through the mirror, it has been deviated. Now, you can checkmate how far in which it has deviated. Okay? Now, this angle of deviation is from this reflected ray to the what? To this extension of this incident ray. Now, how do you get the angle of deviation? You know, remember that the sum of angles in a straight line is equal to 180. Okay? And from the second law of reflection, this states that what? The angle of incidence is equal to the angle of reflection. That is, I is equal to what? I plus R plus D is equal to 180 degrees. The reason is because the sum of angles in a straight line is equal to 180. So we have I, R, and what? D. And from our second law of reflection, that R is equal to I. So we can say that I plus D. Okay. So we say that 2I plus D is equal to 180. So what happens to my D? My D is 180 minus what? 2I. Okay? So if you're asked to find the angle of deviation, this is how you can generate the formula for the angle of deviation. And that is what we are going to use to solve our problem. Is that clear? Right. All right. So let's solve our problem. Now, with what I just explained, a ray of light incident on a plane mirror is inclined to the mirror at an angle of 50 degrees. So we have a plane mirror. Okay, this is a plane mirror. Now it is inclined at an angle of what? 50 degrees, right? Okay. All right, sorry for that. That was network. All right. Now, we are going to look for the angle of incidence and the angle of what? Reflection. Then, for us to get the angle of deviation, we get what? D. Okay? So what do we have? We are going to solve for this. This is a right angle. The sum of angles in a right angle is equals to, right angle is an angle of 90 degrees, okay? So let's solve and get our I. So I will say 50 plus I is equals to 90, right? Then I take this to the other side. That means 50 is equals to, is equals to 90 minus 50 is going to give me what? 40 degrees. Now, if my I here becomes 40 degrees, how do I get the angle of deviation? The angle of deviation, D, is equals to 180 minus 2I, right? That is, D is equals to 180 minus 2 times 40, 180 minus 80, right? By the time you subtract, the answer is going to give you 100 degrees. Is that clear? Now, we're looking at the question. You see that this mirror was inclined at an angle of this to the what? To the surface. That means the angle between the incident ray and the reflecting surface is given as 50. Now, we cannot solve for the angle of deviation without solving for angle of incidence. For us to solve for angle of incidence, we are going to look at, this is a right angle triangle, and a right angle triangle is an angle of 90 degrees. So we say that 50 plus I plus 9 is equals to 90. And because I'm looking for the angle of incidence I, I'm going to minus 50 to get 40. Is that clear? Okay, so my deviation formula becomes D is equals to 180 minus 2 what? 2I. All right, so what do I have? I have, this is D is equals to 180 minus 2 multiplied by 40 because my I is what? 40. Okay, now this is equals to 180 minus 80 and my answer becomes 100 degrees. Okay, then if I is 40 here, here is equally what? 40. But in a situation whereby you're asked to calculate the angle between the angle of incidence and the angle of what? The refraction. The reflection. That is going to be I plus what? I. That is 40 plus what? 40. And the answer becomes 80 degrees. Okay? That is in case you ask the angle between this and this, you now add them together to get 80 degrees. Is that okay? Right. All right, thank you so much for staying and sticking to the end of this class. I really appreciate. Thank you for coming. Thank you for watching. Thank you for standing by. Okay, so we are going to be looking at so many examples as we progress, because the first coming GCE is by next month, which is December 4th. We're going to have physics theory and physics practicals. Okay, then if you're preparing for the forthcoming WAEC and JAM, stick to this channel and follow us the way we work, because we're going to get up something at the end of the day. Okay, I will see you next time in the next one. The more you understand it better. Okay, see you next time in the next one. Bye.